Welcome to Module 3.1 of the Crystal AI tutorial series. In this video, we're going to unlock the full power of Crystal AI in your Node.js backend using the server-side SDK. Whether you're building a REST API, a real-time chat service, or a batch processing pipeline, the SDK gives you a clean TypeScript interface to everything Crystal AI offers. By the end of this video, you'll know how to initialize the SDK, run agents, stream responses, and wire it all up to an Express endpoint. Let's dive in. Let's start with the big picture. The SDK revolves around four core classes. First is Crystal, the main entry point. You create one instance, point it at your YAML config directory, and it becomes your gateway to everything. From there, you call getAgent to retrieve a named agent, or getWorkflow to get a multi-agent pipeline. Both agent and workflow support a run method for single-shot execution and a stream method for real-time token-by-token output. The run method returns a result object with the generated output, token usage stats, and latency in milliseconds. Stream gives you an async iterator where each chunk carries a delta property with the next piece of text. And if anything goes wrong, the SDK throws typed errors from the CrystalError hierarchy so you can handle failures gracefully. Let's look at the code. You start by importing Crystal from the core package, then create a new instance. The constructor takes a config path pointing to your YAML config directory and an optional env object for API keys and secrets. Once initialized, you call getAgent with the name of any agent defined in your YAML files. Running an agent is a single await call. Pass an input string and optional variables, and you get back a result with three key properties. Output is the generated text. Usage.tokens tells you how many tokens were consumed, and latency_ems gives you the response time. You can also access workflows the same way with getWorkflow, passing an input and variables. The workflow orchestrates multiple agents behind the scenes and returns a combined result. Now let's talk about streaming, which is essential for any real-time application. Instead of calling run, you call stream on an agent. This returns an async iterator that you can use with a for-await of loop. Each chunk has a delta property containing the next piece of generated text. You can write these deltas directly to standard output, send them over a WebSocket, or buffer them however you need. Watch the right side of the screen as the response streams in token by token. Once the iteration is complete, you call stream.result to get the full result object with the complete output text and usage statistics. This two-phase approach means you get real-time output for the user experience and complete metadata for logging and billing. Here's where it all comes together. Let's build a production-ready Express endpoint that streams Crystal AI responses using server-sent events. The key is setting three response headers: content type to text/event stream, cache control to no cache, and connection to keep alive. Inside the root handler, we get our agent and call stream with the user's message. Then we loop through the chunks and write each one as an SSE data event, JSON encoding the delta. When streaming finishes, we send one final event with done set to true, along with usage stats and latency. The try-catch ensures that any provider errors or validation failures get sent to the client as error events instead of crashing the server. Finally, we call res.end to close the connection cleanly. This pattern works with any SSE client library on the front end. Let's recap what we covered. You now know how to initialize the Crystal AI SDK with the Crystal class, retrieve agents and workflows by name, execute single-shot requests with run, stream real-time responses with the async iterator pattern, build Express SSE endpoints for production use, and handle errors using the typed error hierarchy. The error classes follow a clean inheritance pattern. ProviderError for LLM failures and validation, error for config issues both extend the base CrystalError class. In the next video, we'll move to the client side and build React components using Crystal AI hooks. See you there.